Of course, using online websites, graphing calculators, it makes it much more easier, much more faster, but we need to know, as mathematicians, we need to know what are the basics. So, example, graph the following. The very first one is r equals to 2. R is 2. The second one is theta equals to 1. Okay, interesting. And the third one is r is 2 cosine theta. Let's take a look at this guy. R is 2. Can we convert R into X and Y? Yes, we know that R is square root of X squared plus Y squared. So square root of X squared plus Y squared is equal to 2, or X squared plus Y squared is equal to 2 squared, or 4. But what is this equation? This is equation.
A circle.
Yes, a circle with center at the origin and radius 2. So what is R equals to 2? A radius centered at the origin with radius 2. That's it. What about this guy? This guy says, hey, theta is equal to 1. Theta is equal to 1. Well, I'm going to take tangent on both sides. Tangent of theta is equal to tangent of 1. This guy is just a number. If you use your calculator, it gives you a number, a decimal number. On the left-hand side, I have tangent of theta. Remember that. We know that tangent of theta is y divided by x. So what's the meaning of that? It means that y divided by x is equal to a positive number. So y over x is equal to tangent of 1. This is a positive number. So what's the meaning of that? It means that y is equal to mx, and m is equal to tangent of 1, which is positive. So what does this guy represent? An increasing line. So this guy is increasing line. This guy is circle centered at the origin, radius 2. Well, what is this guy? So to graph this guy, you have different options. Case 1, or first approach, is to use a graph, use a table. Like the table that we did in intermediate algebra, to graph a line, to graph any function, to graph any map, we can use a table. On one side, we have theta. On the other side, we have r. We plug in different values for theta and we find r. Then we plug those points in our theta plane or in our polar world. So if theta is equal to 0, for example, then r is equal to 2. If theta is equal to, I don't know, pi over 6, then r is equal to 2 times square root of 3 divided by 2 or square root of 3. If theta is equal to pi over 3, for example, you get 2 times a half or 1. If theta is equal to pi, your r is equal to -2. You can continue this process. Find all of these points. Find these points and graph them in polar world. It takes time, but it's a very good practice. Another method that you can use is try to get rid of r and theta, write equation in the form of x and y, the things that you saw before. So in this case, I can multiply both sides by r. We get r squared equals to 2r cosine theta. But we know that r squared is equal to x squared plus y squared. And this is 2 times r cosine theta is x. So what do we have? We have x squared minus 2x plus y squared equal to 0. I'm going to complete the square. X squared minus 2x plus 1 plus y squared is 1. So x minus 1 squared plus y squared is 1. This is equation of a circle. Its center at 1 and 0, and the radius is 1. So the graph is going to be like this. Center at 1 and 0, with radius 1. So this guy represents this circle. R is 2 cosine theta, and it represents this circle. Center at 1 and 0 with radius, in this case. So now that we define this new whole thing about polar equations, we're interested in finding the area given by those equations.